in the gang.
All right, for problem number 35, it says the given function. So they gave us some functions. So let's do this. So from 2.1, problem number 35, they give us some functions. So they say that f of x is equal to 3x minus 21. Then they say that g of x is equal to 3x plus 21. All right. And then it says show that the function show that f of x minus g of x is a constant for all values of x. Okay, well that makes sense. I see why you're asking questions about that. All right. So now, that's a challenging problem. So there's lots of ways you could approach this. I suppose you probably could plug in some numbers and see what happens. But there's a lot of numbers. First of all, what's the domain for f of x? Well, the domain for f of x is, well, all real numbers. So we're not going to plug in every number there is for f of x, let alone have to do it a second time for g of x and see what happens. So what they're asking us to do is kind of prove this logically. All right? So now to prove this logically, how do we go about doing that? Is this 2.1 or 1.1? 2.1. That's the problem though, right?
Yeah.
Okay. So now we want to prove that it's a constant. Okay? So what is f of x? Well, let's try it. F of x is really just 3x minus 21. Right? Okay? Now we're going to take f of x and subtract g of x from it. So could I do this? Could I say minus 3x? Oh, but I got to be careful how I write this. So let's do it this way. Let me do a fresh page here. I'm going to say that f of x is equal to, or not equal to, we have the expression f of x minus g of x is equal to some constant c. Right? They want to say that it's always going to be a number, no matter what.
Okay.
All right? So now what was f of x? It was 3x, remind me because I flipped it.
Minus 21.
Minus 21, right? Minus g of x, which is 3x plus 21 equals some constant c. So now what I need to do is I'm going to take this negative 1 and distribute it through the parentheses. So I'm going to have negative 3x minus 21. Okay, cool. The rest of this stuff is still here, 3x minus 21. And all that stuff equals the constant c. But now an interesting thing happens. This x, positive 3x, and a negative 3x, they cancel out if I simplify and combine like terms on the left-hand side of the equation.
Yep.
Right? It is interesting. Interesting indeed. So now what I'm left with is negative 21 minus 21 is equal to some constant c. Well, I get negative 42 is equal to some constant c. So when I do this, what's going to happen with that x value every single time? Yeah, it kind of cancels out. So if there is no x value, what do we know about the solution of that difference? It will always be a constant. And we even know what the constant will be. Negative 42. Always. And we could double check that. Let me do one more thing. If I say 3x minus 21, and just leave it the way it was, minus 3x minus 21, and then try to figure out what that was, somebody give me a relatively small value for x.
2.
Go ahead. 3, 4. 4. All right. 2, 3, 4. It doesn't really matter. So I'm going to say 3 times 4. So in other words, we're going to let x equal 4. minus 21 minus 3 times 4 minus 21. All right, so I've got 12 minus 21 minus 12 minus 21. What happens with the 12s?
Cancel.
They cancel, right? We got negative 42.
Yep.
Does that make sense?
Yeah.
So now if I go back, somebody said, let's let x equal 2. Well, I do the same thing. 3 times 2 minus 21 minus 3 times 2 minus 21. I get 6 minus 21 minus 6 minus 21. Again, we're going to get 6 cancels with this 6 minus 42. So no matter what value I plug in for x, it's always going to equal 42, which is a constant. And that's what 35 was asking us to prove or show. Any questions on that? Okay, cool. Let's do problem number 37.